So let's get started. Hopefully we know by now how many questions is your quiz. 8. Good. 8 questions. There's only 8 questions. Little bit of everything. It shouldn't be extremely difficult. But I'm just going to go over some of the most important pieces of information that you guys will need to know. I'll skip the Kramer's rule. I'll do one more towards the end. But when you add and subtract matrices, you are going to have some matrix operations that are just addition, subtraction, multiplication. When you're adding and subtracting, you need to have the exact same dimensions. So just by looking at A, B, and C, which ones can you add and subtract? You can add and subtract A and C because they have the exact same number of rows and columns. With multiplication, you need the inner dimensions to be equal. So again, looking at these, which ones can you multiply?
A and B.
Okay, you can do A and B. All right, so you can do A and B because A is a 2 by 3 and B is a 3 by 2. You can also do B times A, right? Because the other way around is true, right? 3 by 2 and then a 2 by 3. These inner numbers are the same, so you can multiply them. What can you not multiply? A and C, right? Because A is a 2 by 3. And C is also a 2 by 3. The inner numbers do not match, so you cannot multiply those. Yeah, you could do B and C, and you could do C and B, right? So no, matrices are not commutative like that. It's not like normal numbers, like, I don't know, 2 times 3, 3 times 2 gets you the same thing. No, if you flip it, the answer changes altogether. Let's do 3a minus 5c. All right, how do we do something like that? Good, so we first want to know what 3a is. And so you're going to multiply every single thing in a by 3. So we get negative 9, negative 3, 0, 6, negative 15, and 12. And then we also want to know what negative 5c is. And so when you multiply every single thing in C by negative 5, you should get 10, negative 30, negative 5, 25, thanks. Negative 10 and, wait, hang on, 15. All right. And since we're doing 3a minus 5c, you're just going to combine the corresponding entries, right? So read me the top row. Good. Good. And that's your top row, right? You just combined the corresponding entries. And now what does the bottom row look like? Good. Yeah, good. So then that would be your final answer. Pretty easy?
Yeah.
Nice. Okay, good. Now let's multiply. So let's do A and B, right? We said earlier that we can multiply A and B because they do have the same inner dimensions. So what I would do is I would write them out. All right, I'll write them out just so that it's easier to follow along. All right, so this is A, and then times B is going to be negative 1, 2, 5, 3, negative 4, 8. All right, and what was our pattern for this? Okay, good, row by column. So it's going to be the row times the column, and you're going to go entry by entry. So you're going to do first times the first. What does the first times the first get you? Okay, good. So that's going to get you just a regular 3. What does the second times the second get you? Negative 2. And what does the third times the third get you? 0. Good. And then we repeat this process the entire way through. So now I'm going to do the first row times the second column. And then we repeat the pattern. What does the first times the first get you? Good. And then second times the second. 4. And then third times the third.
0.
0. Good. And then those are your 2 entries in the first row. All right, now you move on to the second row. So now I'm using the second row first column. So using the second row first column, we're going to repeat the process. What does the first times the first get you? -2, second times the second. -10, third times the third. 20. And then lastly, we do the same. Okay, same exact process with the last one. What's the first times the first in the 6? And then 20. And then 32. All right, and those are your 4 entries. You just want to simplify all of these now. All right, 3 minus 2 plus 0 is going to get you 1. -9 plus 4 plus 0 is -5. -2 minus 10 plus 20 is 8. And 6 plus 20 plus 32 is 58. And then so this is your answer. Your final answer is a 2 by 2 matrix. Are you okay with that? Okay. All right, now finding the inverse, or not finding the inverse, determining if 2 matrices are inverses, you have to multiply A and B times A, right? Again, matrices are not commutative with multiplication, so you need to show both ways. But otherwise, we just repeat the process. So let's do A times B. So 5, 3, 3, and 2 times 2, -3, -3, and 5. But otherwise, we do the exact same thing. All right, doing row by column, what do we get as our first entry? 10 minus 9, good. All right, we did 5 times 2 and then 3 times -3. What about our second entry? Good, right? So we get -15 plus 15. And then bottom row first entry. Good, we get 3 times 2, which is 6, plus 2 times -3, which is -6. And then the last entry. Good, -9 plus 10. And then we simplify all of these. What do we get? Yes, good. And that's exactly what we were looking for. So we showed it this way. Now we want to show it the other way. So now I want to do B times A. I would definitely rewrite it with B times A just because if you're just using what they give you up here, you might confuse yourself with the row and the column. So just rewrite it. All right, so then we repeat the process using these. And what do we get in our first entry? Good, so we get 10 minus 9. And then our second entry. Good. And then bottom row first entry. Good. Or -15 plus, yeah, good. And then we get -9 plus 10. How did I get that? I did -3 times 5. Oh, the first one? Like up here? I did morning things. Wait, hang on. I did 5 times -3 plus 3 times 5. All right, so then we simplify all of these. Do we get the same thing? 1, 0, 0, 1? We do, right? So then these are inverses. So I'm going to say yes. All right, so just an example. Let's just say they were not inverses. What would that look like, right? So let's just say you had the same thing on the side. Just copy the same thing, 5, 3, 3, 2. And then let's just say matrix B was 2, -3, and I'm just going to make this a 3 and a 5. Let's see what that would look like. So let's just say we're multiplying, this is A, this is B. Just to show you what a non-inverse would look like, let's repeat this process. So we're going to get 10 plus 9 right? Because you're doing 5 times 2 plus 3 times 3. And then what does 10 plus 9 get you? 19, right? That is not what our identity matrix looks like. So you could even stop right there and just say that these are not inverses. So that's just an example of what a non-inverse would look like, right? If you had finished this whole process, you would see that your final answer looks nothing like 1001. So just to show you what a non-inverse would look like, it's just anything that doesn't give you this as the product. All right, are you okay with that? Mm-hmm. Yeah, so every single inverse is going to multiply to this 1001. Right, we call this the identity matrix. Sometimes you see it with a capital I, but you just need to know that that's what it gets you, 1001.
So if just something gives you the same exact thing as the other one?
They could give you the same thing, but it needs to specifically look like that. Right. No, like there's no other way, like, okay, I'll finish this one. So we get 19 here, negative 15 plus 15. And then we get 6 plus 6. And then we get negative 9 plus 10, right? So let's say you finish this one. Let's just say this is your A, this is your B. You're going to end up with 19, 12, 0, and 1, right? While this column looks like it does work, this one is not a 1 and a 0. So that's already not the inverse. You can stop right there. All right, but if it works the first time, you should continue it and do it the other way to verify. All right, pretty easy, pretty straightforward. Good. Now, finding the inverse, you just have to do a little process. It's not super difficult, right? So for what we just did above here, and actually finding the inverse, you're only going to deal with 2 by 2 matrices. We don't really deal with anything more complicated than that. But in a regular matrix, so let's just say A is this matrix, A, B, C, D. The inverse of A is going to be 1 over the determinant. Remember the determinant we denote with the straight bars? Times flipping the major diagonals, so A and D swap places, and then flipping the signs of B and C. All right, so I'll show you what that would look like, right? Let's just say this matrix is matrix A. Let's first find the determinants. How do we do that? Good, so negative 5 times negative 2, which is going to get you 10, and it's going to be minus 4 times 1, which is 4. So then your determinant is 6 in this case. All right, so then to find the inverse, A inverse, I'm going to do 1 over that number that we just found, 1 over 6. And then we swap the places of the major diagonals. In this case, it's going to be the 5 and the 2, or the negative 5 and the negative 2. So all we're doing is we're swapping those places. And then the minor diagonals, you change their signs. So it's going to be negative 4 and, negative 4 and negative 1. All right, very last thing that you would do is you would distribute the 1/6 to every single entry in this matrix. And then you would simplify. So what does the top left get you? Good. Simplified is negative 1/3. What about the top right? Good. Negative 2/3. And then the bottom? And then the last one. So then this is the inverse of the matrix that we were given. How is that? Pretty easy process? Yeah, I would say everything that we just did up until this point is about half your quiz. So if you're good with that so far, then you're good with about half your quiz, right? Shouldn't be too bad. All right, any questions? No, we're pretty okay? Okay. Okay, so let's do a Cramer's rule. So Cramer's rule just is a bunch of determinants. So what I like to do with Cramer's rule is I like to first label the columns that we're going to need. What is our X column going to have?
3 and 9.
A 3 and a 1, right? It's the coefficients of x. What is our y column going to have? A 1 and a 1, and then we need the number column with whatever it's equal, which is going to be what? Nice, good. So then we want to find, all of these capital D's just refer to determinants, just different types of determinants. What does this capital D refer to?
X and Y.
Good, just the x and the y. So I'm going to find the determinant of 3, 1, 1, 1. All right, and then what does that get us? So this is going to get us, right, we multiply 3 times 1, which is 3, minus 1 times 1, which is 1. So we get 2. Right, so capital D is 2. How do we find dx?
You replace the equal thing with X.
Good, right? So whatever our numbers are equal to, or whatever our equation's equal, is what we're going to replace with the x column. So it's going to be -9, -7, and then 1, 1 stay the same. And then this is just another determinant. So we're going to do -9 times 1, so -9, minus -7, which is going to get you +7. So dx is -2. dy, we're going to do the same thing. We're just going to replace the y column with -9 and -7, leaving the x column the same. So it looks something like this, and we want to find this determinant. Again, doing the majors, we're going to do 3 times -7, so -21, minus the minors is going to get you -9. So this should get you, you're adding those, it's going to be -12. All right. To get your x and y values, you're just going to do dx over d to find x, and then dy over d to find y. If there is a third variable z, you would do dz over d. So yeah, let's just write it out. So then x in this case is going to be -2 over 2. So -1. And then y is going to be, -12 over 2. So -6. That means your final answer as an ordered pair is going to be -1, -6. All right, pretty easy. Okay, nice. Okay, just for practice, let's try a 3-variable one. All right, these aren't the most fun in the world, but they shouldn't be the most difficult. It's just more time consuming than anything. Right, so again, let's first set up our columns. So what's going to go in our x column?
1, 3, and 2.
Good, 1, 3, and 2. Our y column is going to have a 1, a -1, and a 1. And then z is going to be -2, -5, and 2. And then what it equals is going to be a 2, an 8, and a -7. All right, so then doing the determinant is going to be 1, 3, 2, 1, -1, 1, -2, -5, 2. All right. You can solve this however you want. I think most of us opt to rewrite the 2 columns. Right? Am I right or wrong? Yeah, you do that way?
Yeah.
Okay. So we get something like that. And then we do the major diagonals. So I'm going to write parentheses for the majors minus some parentheses for the minors, right? So when we do the majors, that's going to go in this direction. So this times this times this, and then these, right? So in each diagonal, you're multiplying. So 1 times -1 times 2, what does that get you? -2, and then the other diagonal? 1 times -5 times 2? -10. And then -2 times 3 times 1? -6, good. So then that's our major diagonal. And now we repeat that process with the minor diagonals. So we're going in the other direction, right? So 2 times -1 times -2, what does that get you? 4. 1 times -5 times 1 is -5. And then 2 times 3 times 1 is 6. All right, so then we just simplify this, and then we should get -18 minus 5. Okay, good. And then we get -23. So -23 is capital D. All right, we repeat that process a few more times to get our final answer, right? dx, we're going to replace the x column with 2, 8, and negative 7. And then y and z we're going to keep exactly the same. So 1, negative 1, 1. And then negative 2, negative 5, 2. All right, why don't you guys find the determinant of that? I want you guys to practice that, so give it a try. Okay, yeah, so hopefully we got 23. All right, again, it's the majors, multiply the diagonals, then add them all together, minus the minors. And then we get dx is 23. All right, so we're going to try the same thing 2 more times. Again, guys, this is about as time-consuming as it gets. I would say this and maybe like a secant graph or a cosecant graph might take the longest for you guys. But again, should I put both of those on the quiz, then it's just 2 problems. That's going to be time-consuming. The rest should be fairly quick. All right, so then we're going to repeat this process. Again, why don't you guys give this a try? Okay, bless you. Good, so we get another 23. Good. Pretty easy. Good, and then we do it one more time with z. Again, guys, this is about as time-consuming as it gets. So 1, 3, and 2. For the x, the y's we leave the same. And then it's the z column that we replace. So 2, 8, negative 7. All right, and once again, find this determinant, see what you get. Okay, cool. So then we get wait, what did you say?
1146.
Did I do something wrong?
No, 29 is right. But then you get negative 17, which is 29 plus 17.
Then you get negative 17. Oh, okay, so negative 17. Okay, so you should get positive 46. Okay, good. So you get dz is 46. And then your final answer now, you're just using all of those numbers and putting them right on top of each other. So then we get for x, we get dx over d, which is going to be 23 over negative 23. So we get negative 1. Y, we get 23 over negative 23 again, so negative 1. And then z, we get 46 over negative 23, so negative 2. All right, so then we get negative 1, negative 1, negative 2 as our final answer. All right, good with that? Again, guys, that's about as time-consuming as it gets. I know it's a lot of lessons, but it shouldn't be too bad. I think this is just the only thing that's going to take a little bit more time than the others. All right, so we did this graph yesterday. I left it up here. I want you guys to practice a tangent graph because those are pretty easy, straightforward. But if you haven't seen it in a couple days, you might have forgotten. What do we need first? What piece of information? There's no amplitude and tangent. We just need a period. All right, so that's what makes it a little bit simpler, but okay, what's our period in this case? Pi over 4? Good, right? What if I said pi over 2? What mistake did I make?
Because you put it 2 pi over 4.
Good, right? So in general, tangent is pi over b, not 2 pi over b. All right, so easy mistake to make, just don't forget that, right? The period is, in this case, is just going to be pi over 4. And then just like with any other graph, I need key points, but what am I going to use for my key points? What am I going to multiply by? Okay, halves, right? So I'm going to start at 0, a half, 1, and 3 halves. That's as far as you need to go. And then you're going to multiply the period to each of these. And then so we get 0, pi over 8, pi over 4, and then 3 pi over 8. All right, I also want the negative ones as well. So negative pi over 8, negative pi over 4, and negative 3 pi over 8. And that's really all we need to plot on a graph, right? So let's plot 0, pi over 8, pi over 4, and then 3 pi over 8. Negative pi over 8, negative pi over 4, and then negative 3 pi over 8. All right, what do I do with that information? Where would those go? Okay, good. So on the halves, you're going to have the vertical asymptotes, which means that on the 0 and the 1, what are you going to have? The intercepts, right? That's where you're going to cross the x-axis. So they always alternate intercept, asymptote, right? So I'm going to plot the x-intercepts. And then we said at the halfway marks are going to be the vertical asymptotes. So I'm just going to draw the dotted lines. All right, again and again. Right, and then this particular graph, you don't need to graph the amplitude, the A value, but it does tell you what direction the curves are going in. So from the x-intercepts, where is it going to go up? Is it going to go up to the left or the right, since it's negative?
To the left and then
Good, right? It's going to go up towards the left. So draw it going up towards the left, and then towards the right is where it's going to go down. If it was just a regular positive tangent graph, it would go the other way, so it would go up towards the right and then down towards the left. All right, but that's really all we need to graph tangent. On your quiz, it's going to say graph it over a 3-period interval, right? These are 3 periods. If you see 3 curves, those are 3 periods in tangent. So some important information that you need to have, you just need to have your x-axis labeled. Your y-axis is probably going to be blank. You don't need to label it. Just label the x-axis and then make sure that we can clearly see the asymptotes and where the x-intercepts are, and make sure that it's going in the right direction. But otherwise, that's not one that should take a crazy amount of time. I do think the longer one is going to be a secant or cosecant graph, but the tangent one shouldn't be too bad.
Is it 3 graphs or is it 2? So it's like 1 tangent and 1 secant or cosecant, or is it 1 tangent, 1
Yeah,
secant?
no, the first one. Yeah. All right, good with this one?